Okay, we're going through our review. Try these on your own for the next 20 minutes. So we'll notice that 1 and 2 look very similar. We're taking 5.5 grams of both of the reactants, so aluminum would be for number 2 and BaO would be for number 1, and we're going to convert it to the same product, which is Da for both of them. So we don't really even need to know that there's 1 mole of Al2O3 because we're taking both of our reactants to the same product. Then, once we solve 1 and 2, we'll be able to do 3 and 4, deciding which one was limiting, aka our lower one, and then which one was excess, aka our higher one. And then we'll finish up number 5 by calculating our percent yield, which meant that we're going to take our actual, divide it by our theoretical, make sure that you use your limiting theoretical, and then timesing by 100. So let's get started for this. So hopefully you have a calculator out and ready to go. I just grabbed mine for it too. So, number 1 says if you begin with 5.5 grams of BaO, how many grams of Ba will you make? So, as soon as we see we're going from grams to grams, we're going to have our 4-step problem. Okay, we're going to put our 1 there, and we're going to start with our given first. So we're going to find our given from our balanced chemical equation, aka 5.5 G of BaO. So we're going to have BaO here. That means we're going from this A of BaO to our B, which is our Ba. So we don't need to look at our second reactant or second product with this problem. So we need grams of BaO to cancel out, and we're going to find those from the periodic table. So notice that they were given already for it. Because there's no subscript, we're just going to add 1 Ba. So our 1 Ba is 137.33 plus 1610, and we're going to get 153.33 here, and that's going to be grams always per 1 mole. Whether we write our given grams, it's going to be 1. Whether we find it on the periodic table, it's always going to be per 1. So now we go to our next step, which is going to be our mole ratio. So if we look at BaO, we'll see that there are 3 moles of it to go on the bottom. And then if we look for Ba, we also see that it's 3 moles of Ba. So if we want to, we can simplify this to 1 to 1. I'm going to do that to make the math a little bit easier as we're going through it. Okay, if we continue following our units, we need mole of Ba here. And remember, we're trying to get to grams of Ba. So we wrote down grams, so the opposite one has to be 1, and then we're going to have 137.33 right here. Notice that our units are going to continue to cancel out, so gram Ba, mole Ba, mole Ba, mole Ba, mole Ba, and then we're left with the unit we want. So now we're ready to solve. So let's get our top number first. So we're going to see 5.5 times 1 times 1 times 137.33 gives us the top of 755.315. And then our bottom, we're going to see it's 1 times 153.33 times 1 times 1. So we'll just have 153.33 here. And then we're going to divide our top by our bottom. So we're going to hit divide by 153.33. And we'll see we get this long decimal of 4.926074448. So go back to our given. 5.5. How many sig figs does it have? It has 2. Awesome. So now we're going to round our answer 1, 2. So we'll see we get 4.9 grams of Ba. Now, we can't tell if this is the limiting or excess because we have to do number 2 and convert the other reactant to the same product. So we can check off number 1, done. So now, number 2, we see we're now going to take 5.5 grams of Al, and we need to figure out how many grams of Ba. So we don't need our first reactant or our last product. Let's pre-draw in our lines for our 4, and notice that you're given your elements at the top to help with our conversion. So our given is going to be 5.5 G of Al. We need G of Al to go on the bottom. We're going to find it from the periodic table, and since I wrote G, I'm going to have 1 mole on top here of Al. We look at our periodic table and we see it's 26.982. We can round that to 26.98 as per 2 decimal places that we do in class. Next up, we have our mole ratio. So we find that we have 2 moles of AL on the bottom, and then we're going to go to our BA in this step. We see we have 3 moles of BA there. So notice that our units are continuing to cancel out. So gram of Al, mole of Al, mole of Al. So we see we have mole of Ba here. We need mole of Ba on the bottom. And then what we're trying to get to is grams of Ba, so then we can compare our two reactants. So I wrote gram, I need a 1 on the bottom. So we find Ba is 137.33. So this one, we'll see our mole ratio was not able to cancel out with a 3 and a 2, so we're going to have to find our top answer, and then we'll have to find our bottom answer, and then divide top by bottom. So let's find our top first. So 5.5 times 3 times 137.33. And we'll see we get a rather large number, 2265.945. And then we have to do the bottom. So we're going to do 26.98 times 2, and we get 53.96. So now we're going to take that very large number, 2265.945, we're going to divide it by 53.96. And we notice we get a long decimal yet again, so 41.9930504. Oh my! So now go back to your given. 5.5 would have 2 sig figs, so we're going to count over 1, 2. Will 9 round 1 up? Yes, it does. So we would see that if we had 5.5 grams of aluminum, we would be able to make 42 grams of Ba. So now we have our second reactant and our second theoretical, so we can determine what's limiting in excess. So notice for these ones, we're going to see that if we begin with 5.5 grams of Ba, we made 4.9, and then if we had 5.5 grams of Al, we had 42 grams of Ba. So that was our last one. So notice that what is the limiting reactant? Well, we'll see the one that is lower, so made the lower product was 4.9. Our limiting would be BaO, which was our first reactant, and then we would see the excess had the higher number, so we would say our excess was aluminum. Now, when we're doing the percent yield for this, remember that percent yield is the actual given in the problem, which is 3.24, divided by the theoretical of the limiting. So was the limiting 4.9 or 42? So we would see the limiter is the lower, so we're going to have 4.9 here, and then don't forget to make it a percent, we have to times it by 100. So right now we need our calculator for our final problem for it. So we're going to do 3.24 divided by 4.9. We get that decimal, and then we're going to times it by 100. So we're going to round 66.122448898 to our nearest whole number. So 1, 2, will 1 round 6 up? Nope. So we're going to have 66%. And that's not a bad yield. What that means is that your theoretical was 4.9, you made 3.24 in the lab, and you made about 66% of what you expected. The goal is perfectly at 100, but we might not get there. So thanks for watching this review on the 5 problems going from our limiting and excess and calculating percent yield. Have a great day.